Okay, so my video stopped for some reason, those of you following on YouTube, but I'm coming back for number 7. Move everything to one side. So let's move 100 to the other side, move 100 to the other side. I get 5n squared plus 45n plus 100 equals 0. Let's take a 5 out of everything. N squared plus 9n plus 20 equals 0. And then factor on the inside, n plus 4, n plus 5. Do not lose your 5 on the outside. If you lose him, you will get points marked off. And then last but not least, set each equal to 0. N plus 4 equals 0. So n equals negative 4. And then n plus 5 equals 0. N equals negative 5. All right, I know that was like speed round, but does anyone have any questions? Or are we good? All good. All right, next one. Similar, but a little bit different. Again, look for your GCF. 4r squared minus 4. Does anyone know how to factor r squared minus 4? It would be 2. How would it be in factored form, though? Good, both of them. R minus 2 and R plus 2. Good. So we are doing difference of squares is what that just was. Some of you might have known 4 was a perfect square, so you try to do it a different way, but this one is factoring, so we're going to finish this with factoring. I get r equals negative 2 and r equals positive 2 if you set each equal to 0. Like doing a shortcut now with that answer. I'm sorry, I'll do it better the next one. All right, any questions? Okay, the last one is a little bit of a curveball because it looks super simple. I can't factor it like I've been factoring it. I have to do a GCF. So what's the GCF of negative 5x squared and negative 15x? Negative 5, and then I can take one more thing out. X, good. Don't forget your extra x. So if you take negative 5x, divided that from negative 5x squared, we're left with x. And if I've got negative 15x divided by negative 5x, I get plus 3. Plus 3. I know I'm done because I look inside and I'm like, okay, x and 3, there's literally nothing that can go with them. There's no variables, there's no numbers. That's as good as it gets. Now, do you see how the coefficient out front is not just negative 5, it's negative 5x? I have to set that equal to 0. I have to set that equal to 0 as well as my x plus 3 equals 0. How do I solve that first one for x? How do I get rid of that 5? Divide.
Divide by negative 5.
0. Whenever you've got 0 on top, you get 0. So what some of us want to do is we see the negative 5. You're like, oh, let me add that. So that's why I made a big point to say, like, we divide here because I don't want you to make that mistake. Let's make that mistake now. Let's not make it later. And then last, minus your 3 from both sides. X equals negative 3. All right. Cool, cool, cool. Any questions so far? Okay. Now, the last one, I'm going to show you 2 ways of doing this, okay? There are 2 different methods of solving this. The first method is factoring like we were just doing. So I'm going to minus 42 from both sides in order to get everything to one side to factor, okay? That would be 49p squared and then minus 36 equals 0. If I'm factoring this, my next question would be, is there a GCF I can take out of both of them? What are some things that multiply to be 49?
7.
Oh, it's a perfect square. Okay. So 49p, we could do 7p times 7p. What about 36? Is that also a perfect square?
Yes.
6. This is just like the one we did above, r squared minus 4, except 40p or 49p squared plus 30. Ooh, nothing there was right. Let me try that again. It's just like the one we did above, r squared minus 4, but this time 49p squared minus 36. It's a bigger number, but it's still a perfect square. I'm going to separate it like I did last time. 7p minus 6 and 7p plus 6. That's how it goes in factored form. Remember, I need to do each factor equal to 0. So I'm going to do 7p minus 6 equals 0 and 7p plus 6 equals 0. So I get 7p equals 6, or 6 over 7 is equal to p. And the other way would be p equals negative 6 over 7. All right, so factoring is definitely an option on how to solve these. Okay, there's a second method though. I told you there were 2 ways. The second method is called the square root method. So we're going to be taking the square root of both sides. That means instead of moving everything to one side to factor, we're trying to get just the p squared by itself. So that means instead of minusing 42, we're going to minus 6 from both sides. So I'm going to have 49p squared equals 36. Again, I'm trying to isolate that p squared. So to isolate that p squared, I'm going to divide by 49 on both sides. So I get p squared equals 36 divided by 49. Square root it. Remember, the inverse or the opposite of a square of an exponent is a radical, is a square root. Square root, square root. Now don't forget, so 36 square root is 6, and then 49 square rooted is 7. Don't forget, if we do the radical of both sides, I don't know if we taught you this in Algebra 1, but we have to do plus or minus in front of it. Because either positive 7 over 6 times positive 7 over 6 could have given me 36 over 49, or negative 6 over 7 times negative 6 over 7 could give me that. Do you see how these are the same? Good. Choose one of those methods. Try the next one. Try the one next to it. Mm-hmm. Take like 1 or 2 minutes. Try the next one. All right, you guys ready to talk about it? All right, whether ready or not, here we go. So for anyone who needs to follow along, I'm going to factor first. I'm going to do both methods. So I get negative 4 plus 81 squared equals 0. But I don't like it in that order. I need it to be the difference. So I need the minus first. So 81a squared minus 4 equals 0. 81 has a perfect square of... Whoa, you guys good back there?
No, it didn't.
It's smelling a lot like a new seat kind of class. Assigned seats. I have not done that in a long time. Mike, how do you feel about that? It better be. I didn't really talk my way through that factoring, but 81a squared minus 4, 9a squared would be 81 squared, a squared, and then 2 squared is 4. So that's how I got those numbers. Set each equal to 0, and I would get negative 2 over 9, and I would get positive 2 over 9. If you chose to do it the other way, you do not have to do both ways, but I'm going to just for sake of instruction. If you did it the other way, I would have been adding 6 to both sides. So I get 81a squared equals 4. Divide by your 81 to get a squared equals 4 over 81. And then now I'm going to do square root. That's just, I think, my video from before. I'm not really sure. I'm just going to drag it in the corner until I have to deal with that later. So. So now I'm going to square root both sides. And I'm going to get A equals plus or minus 2 over 9. And that's the exact same thing if I did it the other way. So it worked out. Any questions on this first page? All right, the second page is quadratic formula. I want to do 12 and 13, and if we can get both of those done, I'll give you some time to work on homework. Michael, question? Can you do a plus or minus for that? Yeah, you could do plus or minus there. Yes, so instead of writing them separately, you can do plus or minus. That's a good question. Okay, so we're doing quadratic formula on the back. All right, who has heard of quadratic formula? Who would thinks that they could remember it? Oh, a handful of us. Who does remember it? Colin looks real confident. Colin, go ahead.
X equals negative b and the square root of b squared minus 4ac all over 3.
Perfect. The only thing is I don't think I heard you say plus or minus.
Oh.
Did you say plus or minus? Well, did you say it? I think I missed it, but okay. That's everything else is great. Now, this is something I believe you guys learned back in Algebra 1 when we were online. And so I just assume you guys don't know anything from what you learned online. Does that feel like a fair assumption? Okay, great. So I assume you didn't learn this. So if you didn't learn this, here's the formula. I'm sure I learned it in Algebra 1, but I have distinct memories of learning it in Algebra 2. And I had it as teacher. Her name was Miss Williams. She was very sweet, but she was a little crazy. She would sing us songs. She had a dog named Bronwyn. She used an overhead projector to project on the smart board. So we had smart boards when I went to school here, and other teachers wrote on the smart board. She'd take one of those old school projectors and project it on top of the smart board. And we'd sit there and we're like, is this what our tuition money is paying for? Yeah, and you roll it. There's a little clear thing, clear transparency, and you'd roll it so it gave you more screen. So she'd ride on that. Oh my God, God love her. She was a sweet lady, but crazy. Anyway, she had a song, and I will not sing it, but I remember the song every time I do this. So you know a song. Yeah, there's some more cool songs than that, but she sang a very sweet song to us. That was this, and that's how I remember it. So that's my long story short for quadratic formula. We're going to do these two problems because I think it brings up some good points. The only thing I want to remind you is before we do quadratic formula, you have to be in the form of ax squared plus bx plus c equals 0. So you need your x squared term first, you need your x term second, and then you need your constant, and you need nothing on the right-hand side. You will never have a variable in the quadratic formula. It's just the coefficients. It's the numbers, not the variables. So in order to start solving, if I do this first problem, I'm going to minus 3x from both sides, and it's got to go in between the other two numbers. If there's more things you can combine terms with, go for it, but I don't have that here. So I've got 4x squared minus 3x minus 27 equals 0. Okay, good. Now I'm in my ax squared plus bx plus c equals 0. Don't be afraid to label A, B, and C. I'm literally the only person who's going to see your paper, so it's not embarrassing if you're like, oh, I got to label A, B, and C to know what's going on. What's more embarrassing is if you don't label it and don't do it right and then get it wrong. Okay, let me rewrite my formula here, and then I'll just fill in A, B, and C. So I've got x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm going to erase b, and I'm going to write negative 3. I'm going to erase a, and I'm going to write 4. And then I'm going to erase c, and I'm going to write negative 27. Okay, questions, thoughts, comments so far? Okay, I was really intentional to just substitute in to not solve anything. because I want to remind us, like the very first part's negative b. If my b is already negative, negative of a negative becomes a positive. So now I'm going to get positive 3 plus or minus, and I'm going to start doing all that I can on the inside of that radical. So 3 squared, or negative 3 squared, is a positive 9. All of it's over 8 because that's 2 times a. And then the last thing, I like to do 4 times 4 times negative 27. I don't care if you include the negative in that multiplication or not, just recognize that that's also there. So like in my head, what I'm going to do is 4 times 4 times negative 37, or negative 27, excuse me. And that's negative 432. Now, I did not include this negative, which is why I have 2 negatives down here. If you did include that negative, you would automatically be at the positive. Does that make sense? You guys all clear with what I'm saying? Neither way is right or wrong. Just make sure you're super careful about your signs. Quadratic formula is, I think, like seemingly the easiest, but there's just a lot of room for error if you're not careful. So just be super careful as you do this. Okay, now I add 9 plus 432, which I believe is 441, all over 8. And then especially if it's a number like that I don't recognize, I just put it straight in my calculator and hope that it's a perfect square. And if it's not, then we'll do a factor tree. Oh, but I think this one is a perfect square. I think it's 21. It's not one that I recognize. We just did it earlier today. So if you do square root of 441, you should get 21. Anyone want to affirm me? Okay, good. Okay, now I'm not done yet. I have to do this fraction. I have to actually solve it out. It says 3 plus or minus 21 divided by 8. So I have to do 2 fractions. I have to do 3 plus 21 over 8, and I have to do 3 minus 21 over 8. 3 plus 21 over 8, 3 minus 21 over 8. So then I simplify. 3 plus 21 is going to be 24 over 8. Ooh, nice. That's perfect number 3. 3 minus 21 divided by 8 is going to be, I think, negative 18 over 8. Yeah, not as nice and pretty, but we can simplify it. I do want you to simplify it. So 8 and 18 both have a common factor of 2, so I get 9 over 4. So yeah, that's fine. How did I get the, oh, I don't know why I got the 2. It should be a 4, right? My fault. I just wanted it to be 2 because that's a nicer fraction, but it's a 4. Okay, questions, thoughts, comments. Okay, I want you to try number 13. We're going to go over it together, but I want you to try it. While you're trying number 13, I'm going to pass out any paper homework for anybody. We'll go over that all together, and then we'll be done with class.
want are allowed to, but I like my A's to be positive.
So what our question just was can we have a negative a? I'd rather my x squared value be positive. So I would start by adding 3x squared to both sides and minusing 3x to both sides. All right, so I've got A, I've got B, I've got C. We're going to put it into our quadratic formula. I'm going to make A be 3. Ooh. I'm going to make C -9, and I'm going to make B -3. All right, guys, I need you to join me at the front. Okay, all I did is I decided that I wanted the x squared positive. So I moved everyone so that the x squared was positive. And now I've got -3 is my B, +3 is my X, and -9 is my C. You can get the same answer if you moved the other way. If you added 9 to both sides, that's fine. We just got to watch your negatives. Anybody questions so far? All right, so -3 becomes +3, plus or minus. 3 squared is 9. -4 times 3 is 12. -12 times -9 is a +108 over 6. Now I add what's under the radical, so I get 9 plus 108 is 117 over 6. And then 117 is not a perfect square, but it does have a little factor tree. I've got 9 and 13. It does divide evenly by 9 to be 13. It's going to be 3 root 13. And this is actually going to bring up a really important point. So when I replace root 17 with 3 root 13, I have 3, 3, and 6. So the 3 numbers that are not under the radical, if they have a common factor, I get to take that common factor out. What's the common factor here? 3. So I've got 1, 1, and I've got 2. So my best answer would be 1 plus or minus root 13 over 2. You could write 1 plus or minus 1 root 13, but that's redundant, so I don't usually like to write it. That's my answer. Then you would leave it as it is. Good question, Isaac. And like, for example, if like we got here and then root 117 couldn't factor down, couldn't be simplified, that would be the final answer. But like if you left it here on a test, I'd probably write something like simplify and I'd like -1 or a half or something. Megan. I think you would have a -1 and a -2 on the bottom. So those two negatives cancel out. Does that make sense? Any other questions? You're welcome. Yeah, Alex. Good question. We don't here because I can't do 1 plus root 13 and get like a real number. So this is as simple as it goes. All right, you guys have a couple of more minutes to either work on more of these note problems or to start on your homework. We kind of lucked out to get a little bit extra time. So that's what you're going to do. I see you on Friday online. So make sure this homework is done by Friday. I'm going to stop sharing, and then Ella and Marisol, you guys are free to go.